New software can perform computerized image editing with electric signals from human brains as the only input. This marks a new paradigm in artificial intelligence. Soon, we won't need to use the help function. The computer will sense that we have a problem and come to the rescue by itself. This is one of the possible implications of new research at the University of Copenhagen and the University of Helsinki. The researchers have made a computer edit images entirely based on thoughts generated by humans. The computer had absolutely no prior information about which features it was supposed to edit or how to do it. Nobody has ever done this before, says Tuukka Ruotsalo, associate professor at the University of Copenhagen. The results are presented in an article published at the Computer Vision and Pattern Recognition 2022 conference, the most prestigious in the field. In the study, 30 participants were equipped with hoods containing electrodes that mapped electrical brain signals. All participants were given the same 200 different facial images to look at. Also, they were given a series of tasks such as looking for female faces, looking for older people, looking for blonde hair, etc. The participants would not perform any actions, just look briefly at the images, half a second for each image. Based on their brain activity, the machine first maps the given task and then edits all the images accordingly. So, if the task were to look for older people, the computer would modify the portraits of the younger persons, making them look older. And if the task were to look for a given hair color, everybody would get that color. Notably, the computer had no knowledge of face recognition and would have no idea about gender, hair color, or any other relevant features. Still, it only edited the feature in question, leaving other facial features unchanged, comments Keith Davis, PhD student at the University of Helsinki. Some may argue that plenty of software capable of manipulating facial features already exists. That would be missing the point, Davis explains. All the existing software has been previously trained with labeled input. So, if you want an app that can make people look older, you feed it thousands of portraits and tell the computer which ones are young and which are old. But in this case, the subject's brain activity was the only input. This is an entirely new paradigm in artificial intelligence, using the human brain directly as the input source. One possible application could be in medicine. Doctors already use artificial intelligence in the interpretation of scanning images. However, mistakes do happen. After all, the doctors are only assisted by the images and will make the decisions themselves. Maybe certain features in the images are more often misinterpreted than others. Maybe an application of this research may spot such patterns, says Ruotsalo. Another application could be helping certain groups of disabled people, for instance, allowing a paralyzed person to operate a computer. That would be fantastic, comments Ruotsalo. But the range of possible applications will be vast. For instance, 10 or 20 years from now, we may not need to use a mouse or type commands to operate our computer. Maybe we can just use mind control. Thank you for watching. And please, don't forget to subscribe.